Welcome to the NORR 2024. This year, we address the future of architecture and engineering, as you can see from this year's guest speakers. As founder and host 17 years ago of NORR, my objective was to meet three main goals: to teach, learn, improve, and to do that continuously. The program relies on the best guest speakers in three series: architecture, engineering, and masters. Each of the NORR virtual sessions since 2020 have been recorded and are available on NORR YouTube for global access. This session is being recorded and will be posted in a few weeks. Our guests are invited at no cost through 14 NORR global offices. We're proud to invite 16 schools of architecture in our invited program. Today, I want to welcome to NORR Patrik Schumacher, who is principal of Zaha Hadid Architects. He studied philosophy, mathematics, and architecture in Bonn, Stuttgart, and London, and received his PhD at the Institute of Cultural Science in Klagenfurt. He joined Zaha Hadid in 1988 and was seminal in developing Zaha Hadid Architects, a 500-strong global architecture and design brand. He's received his diploma in architecture in 1990 and has been a partner in ZHA since 2003, and in 2010, together with Zaha Hadid, won the Reba Sterling Prize. In 1996, he founded Design Research Laboratory at the AA in London, where he continues to teach. Since 2007, he is promoting Parametricism as epical style for the 21st century. His current research and design interest is focused on the metaverse and integration of real and virtual communication spaces. Patrik's presentation today will focus on Tectonism, architecture for the 21st century. Please welcome Patrik Schumacher.
Hello, everybody. I'm very happy to be here. Thank you, Sylvia, for the introduction, and thank you to NORR to give me that platform. So I will be talking about an hour and a bit, talking about tectonism, but also how we use AI now to develop this further, and then we will have a conversation first with Niels Fischer, technology director and one of the directors of Zaha Hadid Architects, and then with the Q&A opening up for everybody. So let's kick it off. So tectonism, I've been talking about this for a number of years. Last year, I've been putting out this book, also in Chinese language. And so some of the contents of what I'm talking about, you can find and look up and get in depth about it, picking up that book, which is also illustrated not only with the work of Zaha Hadid Architects, but some other protagonists also featured. But I wanted to also start with mentioning tectonism is a latest and most advanced stage of parametricism. So we're not talking about substituting really parametricism. It's embedded within the paradigm of parametricism, and it's important that, in my distinction, it's part of a cumulative development and elaboration of a paradigm and not a paradigm shift. That paradigm shift was maybe 30 years ago now when we shifted into parametricism in the mid-90s after a number of transitional episodes, postmodernism, deconstructivism, etc., out of modernism. So parametricism is a new epochal style after modernism, and tectonism is this latest stage, a kind of subsidiary style within parametricism. And that's important to know. And so what I find fascinating is that AI now is boosting parametricism. Let's call it parametricism 1.0, if tectonism is parametricism 2.0. In interesting ways, because parametricism, I think, has been very important. It developed very strongly and took over large parts of the kind of academia and young architectural culture into the 2008. Then we had this kind of crisis and rethink, and a lot of momentum was lost in the world of architecture, also with respect to younger firms getting opportunities, etc. And we had a bit of a retrenchment, but it kept developing, kept deepening, but it has not been taking over the field that as it should have done, in my view. So, but what is I find fascinating that now, if you go online, and we'll show you more later, Google AI empowered architecture, or AI architecture, AI architectural design, parametricism seems to be dominant. And that's an interesting indication about the desires and what young architects would like to see. So with respect to, I just quickly rehearsed, I think it's now 2.5 years ago at least, when DALL-E 2 came on, and I've been observing the AI development. And it was wonderful to see how fertile and an interesting tool of creativity boosting and productivity boosting it was. I was invited in with Rafik Anadol as a kind of early adopter. And it was fascinating that we had so much out there in terms of our work that using the phrase Zaha Hadid as a prompt delivered actually quite a lot of interesting quick results. And here it's just, some of the selection of the 100 projects I generate in a few days, which I would have happily kind of incorporated into our oeuvre. And it was quite something. And of course, the world of architecture has to some extent taken it up by storm through other tools like Midjourney and so on. I'm sure you're all fully familiar with that. There's some Midjourney material, or Leonardo, where we generate and help us to ideate and quickly generate options, and it's quite a thrill. And it's quite amazing because I was observing DALL-E 1 and other attempts to train neural networks, the results were very poor for a number of years. And then suddenly something happened, something was cracked. And these sketches are really making sense. They have the right kind of poise and balance for projects. They're quite original and fluid, etc., and new and novel. But at the same time, they sit within a kind of stylistic idiom. They get perspective right. They get light and shadow right. So that's was making these projects really usable, these tools. And we also used it for urbanism, and we started to train up our subsidiary kind of models to guide the overall global, let's say, a big model, and where it's really became very productive. And we also can steer it more with respect to these kind of color-coded zones where we're saying this will be water, this will be land, this will be various types of urban fabric, and you can really quickly generate convincing master plan proposals, for instance, here, to quickly ideate and sketch, and have these color-coded supporting in ordering and organizing with a sketch, a kind of wonderful visualization. So I think that has been quite remarkable. And then you can also graduate how much these models would influence an underlying prompting search, and therefore you would get degrees of your specialized model. With what degrees does it kind of interface and come through the more generic prompting results? Anyway, so these have been incredibly productive tools, and we've been incorporating it into our workflows on a number of levels, and we have a specialized team building tools around that, etc. However, and that is what I was saying earlier, this is Design Architects, but irrespective, just generically, nothing to do with us or no bias. You Google architecture created by, for instance, via Midjourney or via AI, you get parametricism all over the place, maybe 70 to 80%. I think that's quite remarkable, because at the same time, if you look at a certain architectural award, there is kind of 0.00% of parametricism sometimes, like in the design awards, for instance. That contrast is very fascinating, and it's also it really portends the future. It gives us a view into the future, I believe, and I'm very satisfied with this. Not so much afraid about epigons and so on. I just find it fascinating, and I want this transformation to be, that new paradigm to flourish. However, yeah, particularly if all of those who offering trainings and introductions, they all basically offering mid-journey, with mid-journey tutorials. They're all examples. They all generate parametricism projects. So that's quite fascinating. And so we went back. Every now and then I go and explore something like, for instance, the idea of the mega atrium and exoskeletons, etc. So and trying to see if we can get something exterior and interior with some kind of coherence. And these things all work quite well, but when you look more closely, particularly when it comes to structural rationality, for instance, so we wanted to go into tectonism, we can see some kind of irrationality and problems and faults to creep in. So I was probing AI's structural understanding. Okay, great. They're doing wonderful massing models and beautifully rendered with respect to perspective, light and shadow. However, when you're then trying to look for, from footbridges and structures there, it's really all over the place, and the rationality you would want to expect and rely on is not coming through. So I've done a few of those. First glimpse, yeah, these looks like bridges. Major things like the carriageways, for instance, missing. But also, if you go into detail about some of these elements, it falls apart, and you can't really rely on them. It's interesting. It's quite creative. It starts with arches, long arch, and then a kind of trussing. But the details, don't make sense. And I tried this, for instance, with saying exoskeletons with a ZARD prompt, you get really out of control, crazy things. Then I tried to rein it in using Richard Rogers as a prompt in some of these, and is still pushing parametricism in a way that Rogers never would. And they're slightly more controlled, but they're not rational. But still, it can give you an interesting little inspiration. Perhaps. So this is this demonstrating that AI doesn't do tectonism, and that makes sense. It's because it's another level in degree of coherency and interdependencies in the elements and rationality that there is, which is harder, but also the sample base isn't there. Internet isn't full of architecture which has this structural rationality on display and expresses, for instance, structure, but it's other engineering aspects we also include in tectonism, like environmental engineering, like shading systems or fabrication logics, etc. So that's really puts up the challenge. If we want to shift our work more and more from, let's say, parametricism 1.0, which to parametricism 2.0, tectonism at its most advanced, most sophisticated, latest stage, and we want to use AI tools, we have a problem. We have to generate and create these, train up these tools and make them fit for purpose. They're not generically available. And so what we've done, so this is the idea, these are the three categories: structural rationality, environmental engineering logics and rationalities, and then fabrication logics, fabrication engineering. So these are the three themes, and I will show you at the end, we started work on this, and we used a recent workshop at Tongji University where we had a large subscription of students. We picked up, I think, 45, 50 students and put them to work on this and help us, as well as our research team, to go in and train up subsidiary models. And I'll show you the end. We reached somewhere, but we're not fully there, I guess. So tectonism, and we started ourselves to mask out something and train up models and run models. to sketch skeletons and shading elements, etc. So looking at structural logic, but then also tectonic details like this, where it's curved folding, so you could use sheet material, which gives a certain logic and coherency, and this would imprint on the model, and you would have something which follows fabrication logics, rationalization in principle. I mean, you know, as an image at least, pointing you in the right direction. This is something what we're looking for. So we did some of those sketches in preparation for the workshop to test it out. It was just recently, you know, been pushing this, and then went into the workshop, which I come back to at the end of the lecture, by the way. So, yeah, 3D printing and global form logics as well as detailed logics, what we were looking for. And again, these are AI generated and inspired by our Strutsys 3D printed bridge, which is at the same time a kind of Rhino vault compression only structural logic, as well as some seaming, which is to do with the kind of quasi-masonry componentization of this. These things come through. So we're building up a tectonic library of tectonic features according to these three categories, and starting to build up a database of our works and other architects' works to train up specific models, which can then kind of boost the and guide and steer the AI into the channels we would like to explore. So, and as I said, AI will come back to this, but I do need to talk a little bit more about the bulk of the lecture will be about tectonism as such, as the latest stage of parametricism. And this just give you an example what's out there. I mean, a lot of small pavilions, some precursors like Ferrotto and Gaudi, and not much on large scale. There are some things which have been happening, but it's a new research paradigm, and it's a whole movement, and all of that is not only Zahid architects, of course, but many other collaborators like Philip Block and the Block Research Group, ETH, as well as people like Mark Burry, Achim Manges with his Stuttgart kind of team, etc., and sometimes combining structural engineering and architectural teams, research teams together. So these wonderful pavilions, for instance, here. And so that's the look and feel of parametricism. You can see is much richer and diverse in the types of global forms than, let's say, parametricism 1.0, which was mostly blobs and NURB surfaces and single surfaces, let's say NURBs. And here we have ruled surfaces, anti-clastic, that have tensile optimization surfaces, meaning minimal surfaces, compression only, and also the reticulations, the articulations of these surfaces when it comes seaming lines or tessellation logics, that will all imprint rather than having just a kind of white or generic kind of surfaces. So that's much richer, and we'll talk later about it, that this huge richness is also has this nice and beautiful expressiveness, which will feed into the semiological project, which I will talk about. But it's also what draws architects intuitively to this. They love it, we love it, because it gives this kind of beautifully rich repertoire of articulation, of expressiveness we can use to give identity and character to our projects, which is much more rich than what Parametricism 1.0 was, and of course, orders of magnitude richer, I guess, than the minimalist canon. So, and I just want to show, I mean, the terms of the books I've published, Tectonism comes on the back of, started with Digital Hadid, the Autopus of Architecture, Volume 1 and 2, grounding parametricism also in the way architecture should connect up with the theory of society and how this makes sense for societal progress and how it participates in this progress. Parametricism 2.0 had, I didn't use the phrase tectonism, but already started to collect a number of those protagonists I've been mentioning, and was already Tectonism, which has been going on for I would say nearly for 15 years, I would guess, at least. And always with significant delay, the kind of theoretical recapitulation, theorizing, and elaborating the principles and defense on what has emerged in a movement over the years. These are usually kind of retrospective looks. So the definition of tectonism is the most advanced stage of parametricism and implies the expressive heightening of engineering and fabrication-based form finding and optimization processes. And that's, of course, has its kind of engineering and rationality, but it's also, as I said, important for architects with the objective to increase the information richness and legibility of their built environment. That's for us as architects also very important, because architecture needs to speak and communicate, and there's enriched repertoire you can use to make these differentiations and characterize different parts of the built environment so they can become identifiable, and you have a kind of network of similitude and contrast you can use to articulate particular larger complexes where to wash everything in white or everything in kind of a gray NORR surfaces, or minimalist concrete cubes would not be functional in the social sense. So that will be my emphasis towards the later stage of this lecture. So tectonism, matured in the last 15 years as the most promising subsidiary style or substyle of the epochal style of parametricism. And that's an important distinction. As I said, we're not talking about a real paradigm shift. We're just talking about enriching and elaborating the new paradigm of parametricism. So but interestingly, its visual appearance is unmistakably a distinct version of parametricism. So you know it when you see it, delivering a massive increase in architecture's expressive versatility. So in the expressive power of architecture. And that's an important aspect I keep emphasizing. And both parametricism and tectonism, there's a kind of this universal scope of this paradigm and style. It encompasses the whole of the built environment and the world of artifacts too. That is the totality of the human phenomenal world, physical and virtual. And I will not talk about this today, but in the metaverse, we're also using, metaverse is another arena like AI. If you look what's going on, architects dabbling and trying to explore the metaverse, they're using parametricism strongly. And that's quite an interesting signpost of things to come too. But I will not talk about this. So yeah, everything is under the scope. It's like modernism took over everything from urbanism to architecture, interiors, product, graphic. Everything is also, parametricism takes over everything. And but it's also, there's an exclusive competency of the design disciplines. So architecture and design disciplines, from urban design and landscape design to interior, product, fashion, graphic, web and interface design, holds exclusive sway over the perceptual world conceived as user experience. That is, all production decisions with regard to the user interface aspects of this man-made world are channeled through the needle's eyes of our global design discourse. And it's literally, you're surrounded by designers' products, and they all have heard about, Zaha, the architects, I guess, as they had heard about the Bauhaus, etc. And maybe they're not all kind of convinced by this, but what is important, that this discourse is really relevant to everything which we are surrounding ourselves with, and everything which structures our societal lives. That's important for me, to give it a real kind of sense of importance and scope. And I do find that design discourse, the architectural discourse, is currently rather fragmented. So this new book calls for discourse intent on convergence and speculates on the prospect of a convergence around the further development of parametricism and tectonism, to allow 21st century architecture to finally have once more a vital, decisive, transformative impact on the built environment, the way modernism had done in the 20th century, namely to deliver the total remake of our planet's urban physiognomy. So, and that's what modernism did. We had a new civilization. It was the industrial civilization, mechanical mass reproduction, etc., and it impacted. And the Bauhaus anticipated this, and the great pioneers of modernism were all understanding this. Where you take Gropius, Le Corbusier, Mies van der Rohe, etc., that this would impact everything in the phenomenal world, and because there's a new paradigm, and I think we're living in a similarly new paradigm. It's no longer the mechanical industrialization. It is the paradigm of a computationally empowered and telecommunication empowered microeconomic revolution impacting everything, the way we should be working. And it also is hugely impacted, of course, the engineering and intelligence and morphologies coming out of engineering logics, the way they're working now with optimization tools. So that is something which we need to keep in mind. This is at the moment a drop in the ocean. It's a kind of well-known and prominent, but not adhere to marginal trend, which deserves to become a global trend. Let's say if you think about like modernism in the 1920s, a few villas, a few kind of glimpses into the future, but the bulk was still, neoclassical, if you like. So that's where we are at. Maybe we're now in the kind of equivalent of the 30s, 40s, but we haven't reached the 50s and 60s, inverted commas. So that's what this is still kind of trying to achieve. And I'll just give you a few examples of a recent work. And it's not only, it really goes for everything, even kind of mundane and mass products or small products like the kind of refugee tent here. Everything is kind of enhanced, made light-footed, lightweight, highly adapted, and highly rational. But it's important that we understand this concept of style. This is our discipline's category, which is the equivalent of what the category of paradigm does for the sciences. And I'm saying that there can be no rational design process without an underlying explicit or implicit style. It's a set of values, set of methodologies, a set of priorities, and turns of argument by which you keep bringing to your work. And if you would switch that from project to project or within a single project, you get a kind of irrational jumble. So we all have an underlying style, and it is not just, you can see it. There's this kind of visual expressive element of it, but underneath that, there's something which is to do with methodology, with values, and also with the condition in which you work. Okay, so, and this has to be defended because the concept of style has been kind of embattled and critiqued and is seen as something superficial, like a fashion, but it certainly isn't about shifting between, long or short skirts and bell bottoms versus tight trousers, etc., which is kind of these retro cycles. We also have them in architecture, unfortunately. But what I'm talking about is a fundamental sequence where the discipline adapts itself to changing and transforming societal and technologically based civilizations through these styles. And you had, of course, modernism is a big bang. You have, and then there are certain books marking that. So International Style is written in 32, retrospecting over a decade of what has been achieved within modernism. There were also anticipations. Otto Wagner's Modern Architecture anticipated and written a theoretical manifesto before it happened. And then there's this kind of retrospective reckoning, very, very important. And then, but modernism continued to evolve. It had brutalism emerging in the 30s, and then in the 50s, you have the new brutalism, where it really pushes and rolls out and, and enriched, let's say, modernism. And then high-tech emerges as well, 10 years later, etc. Then there's this kind of break where modernism goes into crisis, which is very similar to the way certain kind of the Fordist paradigm and state planning of a simple industrial society goes into crisis, and you have postmodernism, deconstructivism, and you have always these major books marking it, and just say, this is the way I see tectonism. but also my prior books, marking a kind of transition from, let's say, modernism through a series of transitional styles, very short-lived, 10 years of postmodern architecture, 10 years of deconstructism, and now 30 years of parametricism, tectonism. Anyway, I find it fascinating. So it's important to distinguish epochal styles from transitional styles and then subsidiary styles when you have a long-term paradigm where you go through, you develop within that paradigm and you're still innovating, you're still building new features. And that is, I think, an important set of categories which applies to the world of 500 years of architectural styles. You can use that to make sense of it. And it's important that in general, what we have to see that these epochal styles, not the subsidiary styles, they tie in with socioeconomic epochs and technological epochs, if you like. So that's the meaning of these paradigms. It's adapting the discipline to the larger societal, historical societal dynamics. And that's the really also to be looked at. So it's something really deep concept, and it's not a kind of fashion cycle, clearly not. And anyway, I will go a little bit faster over these, but you can see here that these major epochal styles, they had subsidiary styles. Historicism had the neo-Gothic into neo-Renaissance, neo-Baroque into eclecticism. Modernism had the white modernism first, the functionalism in parallel, the organicism, then and rationalism, then brutalism, metabolism, high-tech. And parametricism has gone through a number of subsidiary styles. I mean, we are 30 years in, so we had, I will distinguish foldism, blobism, swarmism, and tectonism as the one which I think really stands out. And then you transitional styles. We also, between, let's say, historicism and modernism, we had Art Nouveau and Expressionism, very, very short-lived episodes, which signaled historicism can continue. We're looking for something new. We want to experiment. And then the consolidation into a paradigm which kind of clears the market and goes for a 50, 60, 70-year process. And then again, a big crisis and break, postmodernism and deconstructism, short-lived experiments. You can also say minimalism comes in as a kind of retro attempt. But ultimately, I think, and of course, we haven't achieved what modernism achieved, clearing the market. We are kind of not there yet, but I think we'll get there. And when I showed you what the young generation is trying to do with respect to just looking at what AI is generating or what metaverse is doing, and when you metaverse architect, you can a kind of 25-year young architect can generate solutions and can outcompete major firms with 30, 40 years track record. So that's where you see the future. That's anyway my hope. And parametricism, emerged in the early 90s. Was at the beginning was called folding in architecture, experimenting with a lot of computational tools, and it was toying around. It was marginal. It was experimental, but then a whole discipline, a whole kind of generation of architects went behind it, and it moved through trying to encompass, larger ambitions like parametric urbanism, etc. And so 15 years in, I was starting to coin that phrase and talk about and publishing about parametricism, the new global style of architecture and urban design. So again, retrospectively, like all the other kind of coinages, you don't know it in advance, but when you look back at 15 years of consistent research and build up, hey, there's something which deserves to be named, deserves to be looked at more carefully. That's not a kind of quick fashion. And what Mies said, you can't reinvent a new architecture every Monday morning. That's when we're talking about epochal styles. And basically, people who've seen my lectures before, I'm using that slide all the time. It really tracks the shift from modernism to parametricism, tracks that transformation, that epochal transformation from Fordism to post-Fordism. When it's kind of static hierarchy, mechanical mass reproduction, seriality, and where you can make a huge boost of prosperity, but, single standard of consumption, equalization, but also, in a sense, quite boring work routines, and not a lot of, you know, quite kind of boring set of repetitive products, but a certain degree of affluence unheard of before. And now in a different world, all these people who used to be here, they now can do research, development, finance, marketing, innovation, and you can reprogram the robots. So we're all working in this dynamic ecosystem of the knowledge economy. We're all creators. We all kind of can innovate, and this new technology can absorb an enormous amount of innovation, and you kind of customize and bring out new features and diversity of product, what's called flexible specialization. It's a totally different also than city. It's not these greenfield factory cities, but it's the knowledge economy hubs, these kind of dense clusters, live, work, communicate, not 9 to 5, but ever learning, ever infotainment, ever, et cetera, et cetera. So it's a totally different task and totally different tools and a new society, which is much more exciting, it's much more thrilling, maybe a bit more anxiety because it's less stable. But that's what parametricism fits into. And that's why it's epochal. And if our architecture looks like it would, you know, fitting in the wrong era, we're in an anachronism we shouldn't be in. So here's just showing you that these styles become then also research programs. So where you explore, but you know the principles you want to explore accordingly. So you have certain research programs, everything malleable, everything parametrically variable, everything correlates across systems. So these subsystems, which are all, let's say, internally differentiated, they're all also correlated in an interesting way, rather than separating out and keeping separate. So we have these kind of heuristics, these value systems, and I'm not going to go into detail here, but they're both formal in terms of the formal repertoires we now employ, but they're also representing functional heuristics, that we're not in this world of social homogenization, that we're not in the world of segregative zoning, but that all functions are variable event scenarios, and all functions communicate and interact with each other. And that mirrors basically this idea of system differentiation, system correlation, and malleability and adaptiveness, et cetera, et cetera. So there's a kind of sociological, societal logic to what become these kind of formal logics and principles and methodologies of the style. And in the book, I start also with rehearsing a bit parametricism, and I will go a bit further, and that the different stages of parametricism, and that tectonism is the latest stage. I mean, these are interesting expansions. So the idea of swarms of elements making fluid forms rather than just single objects, it was amazing. But so these are interesting transitions. I remember them very well. I was part of it from day one. But tectonism adds much more because it is really integrates with all the engineering logics in fundamental ways. So I think in terms of the steps, this is the biggest step. And it also makes it harder to participate quickly and easily. You need to learn more, you need to understand more, and you need to learn more tools. I mean, Grasshopper worlds and plugins help, but you need to be a little bit more intelligent and educated to do that. But to go back, so foldism, of course, it was fascinating that you said, okay, instead of having a series of dissected spaces, that you can articulate space through kind of these ripples in a surface, and you can distinguish zones without really separate them, but articulate them. And that will be a paradigm of a single surface generating a whole architecture, was kind of pretty original and novel and unusual and out there, really of the order of magnitude of initially, like, let's say, when a style sketch of a Piet Mondrian or Elizitsky Brown said, that's the new architecture. It has an equally dramatic conditioning, and we've seen that in DRL. We've started that in Zaha Hadid Architects. One of the first examples, FOA's projects, or came out of Eisenman using these pleats and folds. Wonderful work. And let's say a mature version of this is our Baku project. And these surfaces continue and they're modulate, and instead of pacing together a staircase with a ceiling with light fixtures. Everything evolves out of a single surface, and you can have an overall complexity which remains legible, and you focus on the spatial dynamics, and you're not distracted by, rather supported by these articulations. You can then introduce differences in materiality, but there's also continuity across typologies. So these are the kind of works, or blobism, these blobs, where you can, it's again not boxes and boxes or boxes next to boxes, but degrees of fusion, the degrees of integrating different domains. And there's a kind of gradient and variable parameter. So it's moving from set theory logic, where you either have separation, inclusion, or intersection, into this kind of fuzzy logic, which is much more potent and expressive and variability. And we have these projects to exemplify this, and we've been delivering on scale and across typologies, on foldism, on blobism, and then swarmism, that you can have swarms of elements which cohere and articulate a massive differentiation. You can affiliate to existing urban conditions. You can then gradually have quite dramatic variations, but they're ordered, and one thing flows to another, and there's an underlying order and not a kind of random jumble. And these are highly articulate and highly legible and easy to navigate, I think, environments, and you can integrate existing structures. And that is also what your envelopes, the way elements can adapt to different conditions, yet be part of one system. So, and that applied to urbanism, applied to many things. So tectonism, again, I started to talk about, I guess, 2016, 2017. The book came out 2023. It's a long gestation, but I think the first glimpse at this was already visible in 2000, when we had this opportunity, sad and thrilling at the same time, to remake a fantastic New York monument. In the end, the outcome wasn't very satisfying. But this competition, Lars Spyberg, who was one of the protagonists, inspired by Frau Otto, and I was, by the way, kind of a Frau Otto student, but it hit everybody once we realized this should come back, and Frau Otto is the precursor of not only parametricism, but of tectonism. So that's when it started, and the work of Frau Otto is amazing, and we've been, of course, inspired and been working with shell structures, tensile structures, carbon fiber shells, etc. And again, tensile structures, and using structural logics and different materialities to generate a morphology which has a much more rigor and principledness, but it fits into parametricism. It's not an ERB surface, it's a kind of minimal anticlastic surface, and you get these families of forms which are distinct through the particular logic, and therefore you get this heightened rationality and heightened precision and predictability of the form, if you like. But it's open. It's really based on the irregularity of the footprint. And then you have, Mark Burry as well as Lars coming in, and you had actually 2004, Neil Leach curated Digital Tectonics, where they started to get the first glimpse. I mean, these examples are not particularly worked through rationality, but there's a glimpse, a research paradigm. So we're really talking about, by now, in exactly 20 years, where this phrase came up. Nobody was talking about tectonism. Nobody was even talking about parametricism. But the seeds of what we now call tectonism were started to be in gestation. And so Frei Otto was an inspiration, and so was Gaudi. And that's why also, because of something like digital tectonics, the phrase tectonism, as I was struggling, how should I call this new word, this new phase, I got glimpses towards that naming. And also in Jesse Reiser's Atlas of Novel Tectonics, where you see glimpses of an early tectonism, if you like. And you can see the kind of examples they look at. A lot of this, certain structural systems and system types, but also the fluidity and transformation. And engineering at the time, yes, they started to use finite element analysis. You could use optimization also over non-symmetrical and more integrated networks of force flows, whereas in modernism you had to cut everything to reduce complexity, and to make to allow for fabrication, it had to be simple kit of parts, mass reproduced. So these are the kind of signals of that we're onto something new. And at DRL, we did this kind of inverted Gothic, but it's not only compression, it's compression and tension. Instead of repeating base, iterated base, and you get a beautiful structures there. It's Maria Tironi and some of the colleagues from DRL, as well as in Vienna. In that period, we did some of those things, grid shells, where we were particularly keen on the differentiation that you have singular directed network, chaotically network, gridded, and you can articulate a space, the different zones, so it's orienting instead of having one kind of homogeneous space. So it's a kind of mirroring, but not only it's the form of interest, but the reticulation and structural logics help to structure such a space. So these are the things we're looking at. And we also looked at other examples in shell structure, and you can see that you can heighten it into ornament to differentiate the different kinds of spaces. Anyway, so tectonics as the principal term, of course, this has its long history, particularly within German architectural theory of the 19th century. The tectonic der Hellenen, the tectonics of the ancient Greek. And of course, Semper's majestic, the style and the tactical and tectonic arts, which is basically some kind of origin of species, a kind of version of, the equivalent of Darwin's origin of species in respect to the manifold and the world of human artifacts and constructions around the globe. And for the first time, one could get a glimpse of this in the great exhibition in London, where Semper resided, and he saw that kind of huge, for out of the British Empire, bringing all these cultures and structures and artifacts together, and he was able to do that. And kind of the phrase tectonic is a key element here, and these of course are structural and fabrication rationales, and the Gothic, of course, etc. So and I've also said we brought this one in recently, the Vieux-le-Duc, in the 19th century, experimenting with combinations of systems like vaulting, brick vaults, and cast iron kind of lattices, etc. Of course, still more crystalline, more symmetrically ordered, point symmetrical, and not yet tectonism. But these are wonderful examples and quite innovative. And we had to wait, I guess, a long time before something like this would be really realized. But also an interesting point. You had that slide as well in your introduction, Silvio. So we had in modernism, the first modernism was this white abstract cubes coming out of modern art, the style, the free composing, free facade, but with people like Frampton in the mid-century, there was feeling there's something that was missing. There's this kind of no sense of making, of structure. These things are kind of denied and under kind of white painted surfaces. Particularly also these buildings were small, so you didn't have much structural work, and you could hide it in between the kind of, as if it was a stretched canvas. So this was an important signal. So examples, of course, of Utzon, of Flank Lloyd Wright, and the idea to give more richness and articulation back to architecture coming out of these tectonic logic. So it's another interesting reference. And similarly, I would say parametricism to tectonism is similar, kind of from the modernism of the 20s, 30s, 40s into this, the 40s, 50s, 60s, and embedding and enriching the repertoire and articulation. So we're in a similar stage. And okay, so I have these three drivers: structural system optimization as driver of tectonic articulation, environmental engineering logics as drivers of tectonic articulation, and then fabrication methods as drivers of tectonic articulation. And these should now imprint strongly, but in total coherence with the general principle of parametricism, onto architecture. So we have these three types of engineering logics structural, environmental, and fabrication. And I start with the structural systems. And of course, traditionally, there's never been a way out of that. These morphologies are of course structurally determined, and these forms weren't freely invented, but then they were also kind of became types and heightened and aesthetically demanded systems of proportions, are in a sense kind of aestheticization and canonization, dogmatization of systems of structural logic. And the tessellations came through, then they were then kind of became also ornamental feature. But one thing is significant: these were all crystalline aside. Symmetrical structures is the only way you could do them. And then to do compression only masonry walls on free plans, that's the work of Philip Block at ETH, and then available to everybody now with Rhino Vault, and super thin, super light. These are equilibrium structures. Static graphics applied to, this is not force analysis, this is pure equilibrium geometry analysis. It is wonderfully thin kind of marble shells, and the tessellation is also articulated. So wonderful kind of experiments, and that's tectonism at its best, but of course, single system at the point. These are pavilions. We worked with Philip, and we learned also from other compression-only stone structures and did some sketches. The next thing is, principled stress lines, tools like Caramba. If you had to do a kind of a Nervi today, that's the way you would do it. And you can see immediately the beauty and the articulateness. You can guess where the openings are, they radiate through, where the support points are coming. And it has an elegance and beauty and coherence and an efficiency, which we love. And you can apply that then to shells. So you have the double articulation of the global form and then the detailed articulation in terms of structure. And then we kind of looked at people like Candela, and we did a kind of Candela revisited, and we integrated the three hyper shells and articulated them primary stress lines. So these are the kind of experiments in tectonisms, highly articulate 3D printing as a fabrication, but underlying this is shell formation, first of all in the global form, and then topology optimization to get the reticulations or reinforcement patterns, and then creatively, there's always creative moves. How do you express that? Just in kind of gradient densification towards the ribs and the deepening towards the rib, etc. And you get something super organic, super light, super articulate. And it's a new aesthetic you immediately recognize. And something, wow, what's going on here? And you say, wow, pick that thing up, that's super light. But similar principles of these shell topology optimization, they're not 3D printed, but through sheet material and straight lines, so you get a different fabrication. So it's similar in terms of structural logic, different in terms of final fabrication logic, and you get these kind of similitudes, coherencies, and differences, and you can really play a beautifully nuanced repertoire of tectonic articulation. And similarly, we're starting to use it to towers, and if you look back at the textbook of tower structures, they'll tell you that you can use a framework up to whatever 100 meter. Then you need to bring in the central core, and beyond that you need to bring out riggers. Then you go into the tube as if you had to jump from one system to the other. And you can see the irrational presumption is that the whole tower is one single system, all of it top to bottom, and in each subsystem, master production technical elements are repeated, and you can take this tower and turn it upside down, and it's the same form, the same logic. This is fundamentally irrational if you apply contemporary logics to it. And we are saying, no, this needs to be differentiated, and you don't need, you will see and show how the forces accumulate, particularly horizontal forces accumulate and superimpose, and you get something very different between bottom, middle, and top. And you can show this and articulate this, and we've been using this, and then you can, when you then bring in your occupiable surface, you can kind of then interface this and correlate these, and you have 3 apartments, and the lower part 2 apartments, and in the mid part, and then one apartment per floor at the top, and you express it with these balconies, etc. And it makes sense. These towers make sense, or something like this. Sorry, there's noise here. I just took this off. You know, an exoskeleton which gives you this kind of unbelievable freedom on the inside, and where you can fly through. You don't have a central core. You can fly through as panoramic elevators, and you separate the subsystems and differentiate them and articulate them tectonically. And you get kind of project like this where tectonism starts to scale up in these projects, also in medium and small projects. So that's just, I will click through quickly. And again, timber, concrete, steel, and the carbon fiber, etc. And the heightening of this, like traditional architecture always has done, into some kind of expressive characterization and differentiation of the space. And there you have degrees of freedom. So once you have, this is the logic of flow lines, of structure lines, you can extrude them with this or that density, you can generate them into a crease, and you can, this is still all rational. But there is this kind of repertoire of articulation which comes in. You can make perforations, etc. So even within one system, there's a lot of leeway to articulate and express, and that's important to us, and nearly have in kind of ornamental heightening of that. And so shells and tensile structures and the combination of such and tensile structures give character in our work, and that scales up to the big projects we are looking for to deliver, and they help you navigate. You know where the orientation space is the biggest span, where you can follow structural lines and light lines, etc. So these are recent projects which work with these principles: global form, structural reticulation, patterning, gradients, which also then show up where the light penetrates, etc. So this is what we've achieved, and again, it's more sophisticated, it's more collaborative. We need the engineers to take a much more active role early on and impose themselves more, not just let us do, and then later on they stitch something up behind the kind of behind the rain screen with massive pochets full of kind of wild structural steel. No, we want to expose it and use it as expressive medium. That's what we're trying to do here. And again, Friotto and research programs, Harvard, I did this project with, tackling something like Google Campus. And again, different teams using different systems. And after I worked this through, so this is kind of the Friotto wool thread path optimization network of structural lines. These are active bending grid shells. These are catenaries upon catenaries. But it was interesting, although they're lovely parametrically differentiating, I felt all of them were by themselves too homogeneous to really articulate a large complex like Google Campus. And certainly better than the old parametricism would have been, better than a minimalist version. But still, we needed all three systems maybe come together into kind of coherent to really articulate all the differences programmatically and give them expression. So this is just the critique that we have three projects which are single system, however nicely parametrically varied and however much structurally rational. These three systems and more should have been in one project. And then we started this in Vienna with a group, and we said, okay, we have different structural logics and generate a cultural complex, and we get more variety and more articulation and more identity, yet maintaining coherence, because they're all tectonism projects. And they all have kind of parallel and related logics, and they make sense. Or this world of towers. I mean, again, I'm using a lot of academic research, DRL again, different topology optimization tools, and how they tie in, how they might be translated in concrete, steel, or timber, etc. And I will come to that later. And you get something kind of which is more differentiated and recognizable, where you said these are the residential towers, the office towers, the mixed-use towers, rather than having, 50 equal and identical towers like they're still developing China at this point. And having, differentiation also between bottom, middle, and top, etc., etc., etc. So that's the world of tectonism, which we're exploring, and where you obviously need the tools to get there. So this is within 9 months, 10 months, you can get a small team of 3 or 4 students can deliver a whole cityscape detailed out to this degree, and that's all pre-AI at this point. So environmental, we've early on started to differentiate shading systems. I mean, you have these curved forms. The way the sun hits will be different at each spot and point, and in some areas there's less shading, so you can have a kind of sun exposure map, and you can then let that drive the differentiation of the shading elements. These are the kind of things. Or you have a project like the Central Bank of Iraq, where you can have quite different ways of using structure and shading, and the tower looks quite different from different sides. It totally closes down, and if you have that kind of tower, you can really use it as a landmark. Where you if you look at a closed facade, you're coming from north, looking at south, and it's totally open facade, you're looking the opposite direction, and it becomes a kind of really an orienting beacon, as well as rationally adapted to the sun exposure and maximizing light, etc., and minimizing expense in terms of louvers. And similarly, this project in Saudi Arabia, where we're looking at sun and wind capture to ventilate courtyards, types of spaces, and you have the same parameters of bringing in air and keeping out light, which in a sense apply both to the solid volumes and to the canopy, and they kind of respond to the same parametric layers, so they unify across layers, and you get something more integrated, both differentiated and integrated. And you can see that then external courtyards are also kind of mirrored with glazed atria, and outdoor shading events. And you get something which is, in a sense, rational, unified, differentiated, but also you sense it's part of the environment. It's embedding it into the climatic conditions, which makes it similar to some extent, has degrees of similarity even with traditional regional architectures, because of the climatic conditions, also certain typological conditions. So these are kind of seminal projects for us. And you can see here, this project foregrounds environmental engineering, some of the projects foreground structural engineering, the Iraq integrates structural and environmental, etc. And when it comes to fabrication, again, a huge number of factura imprinting, which you could use to differentiate, to make expressive. Of course, here there are shell logics and fabrication and carbon fiber logics, and there are different versions of this. And these are the pavilions of Achim Menges in Stuttgart, or a former student and colleague of ours, Mark Fons, doing these kind of shell structures, fabrication and structural logics foregrounding. ZHA code, curved folding, as fabricating in a global shell form, etc. And then also not being shy, you have to bolt these together, and the rational pattern of bolting adds plasticity and character as well. So everything becomes kind of utilized as an expressive tool, rather than using engineering and then kind of covering it all up with white and then maybe wallpapering on the articulation. No, it's much more truth-telling and satisfying that the actual tectonic logics become the characterizing morphologies and inverted commas ornament as semiology. That's very important to me. And of course, that means you need to kind of also select the systems with respect to expressiveness. But since there's so many choices of systems at any point, that you'll find enough to orchestrate your palette, never stepping out of rationality constraints, but not, the final choices are also inverted commas, artistic or social functionality semiology choices, always backed up by, let's say, engineering rationalities, and that's very satisfying. And you know, the engineering rationalities also bring coherence, and you can feel it and track it and understand it. There's a kind of differentiation logic in there. So, and it is very important that my work in the book and writings, you have this movement going on for 15 years. This is kind of post-rationalization, a theoretical program of moving forward, similar with parametricism as a general paradigm. And to do that retroactive manifesto, there's an empirical kind of stock taking, reconstruct what has been achieved and explicating its rationality, which wasn't so explicit, and then making that a normative model going forward. So I have to rush on, but my particular contribution is that rational reconstruction and explication, but also adding on that enhanced agenda of what I call tectonic articulation. So morphologies, both global forms and details delivered by the various types of engineering optimization, are selected, visually enhanced to become conspicuous, and then orchestrated in the ambition to design an information-rich environment that conspicuously and eloquently communicates its organization and offerings to end users, thereby facilitating navigation, interaction, and enhancing social functionality. So this mantra of the postmodernists, architecture must speak again, is still part of this story. But instead of randomly and arbitrarily speak with pastiches and colors, we let the underlying, let's say, engineering functionalities together with requirements from the social flows and functionalities do the speaking. And the difference with some people like Frampton and his idea of tectonics is this is not only and not necessarily and primarily a didactic or explicating structural logics and fabrication logic, because that's the end users don't care. That's for us internally. But the articulation is really articulation of the social events and characterize them and encoding them with not colors, but with these tectonic systems, let's say. And again, I show you some examples of how you work with algorithms, DRL, and that's been going on for quite a bit. And you get these beautifully differentiated organic structures, which become legible because they're logical. You can follow the gradients, you can follow the logics. And like you can follow an environment out there where you have logics of, you know, lush sides of the mountain, dark and cold sides of the mountain, close to the water, away from the water. And in a kind of evolved environment, you can find things, and animals can find things, because there's a logic you wouldn't be able to find in a city, which is like a garbage spill. And this is also for us, for our sensibilities. So tectonic articulation is service of signification. Engineering logics deliver technical rationality and double up of expressive resources for articulation. And articulation is a core task for architects with respect to information, orientation, navigation. It was always like this. Ornaments were always about expressing and characterizing and telling your audience what you encounter, what is where, and what's the different character of the events you want to expect. So these tectonic exercises, this kind of interesting network of contrasts and similitudes you can use to express and paint your complex social order. And I mean, it was always done like this. I mean, it's, you know, where you use Doric versus Ionian versus Corinthian, they were tied with typologies, they were tied with levels within the building. The rustication expresses kind of the workshops and kitchens, and and etc. So you have ornament, tectonics become ornament, become semiology. It's been throughout the history of architecture. And you know where the private zones are, where the piano nobile is, and where the kind of serving zones is. And it's also when we do utilitarian projects like this, and I have to be quick here, where we worry about legibility, that this car and ride scheme, two car parks across the street, a tram station, and a bus station would totally disappear in this kind of disarticulate no man's land. So no, we articulate, we make legible, we make usable, and that enhances the quick navigation and finding your destinations and moving through. And every thing is technically viable, but we make choices where we orchestrate the different morphologies and technical elements to create that, let's say, composition, but it really has a social function. It's not a piece of art. It's a piece of information design, which is self-explicatory and leads you through the project. And you can anticipate where the tram is, you can see how things connect, you can follow a gradient of lampposts. The curve helps to tie things together, even though this thing is going across, ties together across the street, which cuts through it, but we can kind of allow for that. Anyway, so this is the kind of idea of where in the end there's a strange similarity between the ceiling of that station and the ground, but that is motivated because they both participate in articulating and orienting you through the project. And there's no technical compromise in any of these. They're all perfectly viable. Anyway, so these are, and then, if you go to a university where you have different departments and types of schools and types of seminars and lecture halls, etc., you have an intricate network and matrix of articulations. You can use tectonic shell formations they're never irrational. They always also articulate nicely zones and subzones. Anyway, I can't have time to go too much deeply into this, and you can align them with functional types and articulate them across and be systematically and coherent. So you really build up a semiological system, a language where the vocabulary is all coming out of tectonism of engineering rationalities and functional rationalities, where you can combine, overlap, intersect, etc., and you get something which is in the end highly articulate, and you use these algorithms to make it happening, and you use different systems like before, not the homogeneity of the Google campus we were discussing, but something much more rich and differentiated and articulate. And of course, you don't know how to read this, but in the end, when you're in there, there's always these kind of references, what belongs together, what is where, how to navigate, how to follow this. And bringing all this to bear is the project. And again, we have developed the semiological project, and I don't have time for this. It's a kind of subsidiary research strand. You could also do a pre-tectonism through morphologies, but there is something where you differentiate the field according to logics. You reuse languages for global spaces, but then that reoccurs on the level of furniture. And you know the difference between meeting zones, co-working zones, public interaction zones. There, with respect to distinction like open, closed, convex versus concave, etc. And now imagine another kind of tectonism overlay over that. And that would be able, if our environment would have been so kind of rigorously structured, we would be able to take it in, like somebody can learn, dot matrix late in life, and run her fingers, his fingers across this weight and take in a lot of information. That's the dream, that the built environment has that kind of deep structure. We would realize it pays off to pay attention to these features, and you're learning a language as you move through space. Now that's the program of tectonism. And now again, go back to AI should help us, because we want to generate this on scale and use the aid. So we've been training up these systems, and we've been looking at these repertoires, and then also differentiate. So while we were teaching at Tongji, we also started to prepare, and you can also make not only structural logics, fabrication logic, concrete, steel, timber, etc. And we developed this tower where you also shift through the system, through the materials. And we have that while we were teaching the students, I was sitting down with the team itself, and we developed this in a few days as well as an example. And we're doing these theoretical projects. Sometimes there's no client. This is just showing how you can express functional differentiation, align it with tectonic structural systems, as well as brise-soleil and shading systems, and we get something quite articulate, quite rich, and expressive, which also tells you where these functions shift, etc., etc. So it's a kind of little theoretical exercise, and you can see here the kind of the depths of facade in the south, in the west, where you have more vertical extrusions, and you can read off the sun orientation directions of this artifact as well, as etc., etc. So with that, we went to I'm just closing a few images. These three kind of learning curves, sampling these examples. Sorry, I had this training up, building up, training up, doing these these kind of models, topology optimization, structural logic. It generated a lot of sun exposure things, and feeding the AI with these kind of examples, which were actually generated during the workshop, and then kind of asking the AI to output this. First, we had a number of single systems, so structural only outputs, environmental only output, and then we also started to combined outputs. So we managed to get, I'm not saying this is with different student teams, a total of 50 working on this in various teams. Within a week, we generated something where we, again, just to rehearse that, had these three strands: structure, fabrication, environmental, gave them a massing model to apply this to, and then let them inspired and work through this with several different optimization tools. Some more we felt like amoeba and an erosion model in the vertical more conducive for concrete translation, peregrine, all of the linear elements more conducive to let's say steel and timber. And we generated these examples. Then fabrication, we looked at timber, concrete, steel, and developed details. Environmental, we looked at sun exposure and how and different functions would respond, and different details would come out, and generated basically the input into the AI, trained up. The students learned how, then I said, always kept be more conspicuous, push more, more depth, more relief. So there's a slight kind of aesthetic heightening to bring it home, and then training the AI, and then later on prompting the results. And generating, first of all, these are, AI generated elements, and then kind of collaging it together on site. So that's where we were, and I think it's exciting, and it's not there yet, but it's a research program which continues. But I think it's important that tectonism is such a tough thing to learn, and as these tools become more intuitive, and if we can use AI to push this way forward, it's very important. So I'll leave you with these remarks and maybe stop sharing.
Patrik, thank you for that. This series this year.
Silvio, I think you're muted.
Can you hear me?
No, I was muting my computer.
No problem. But Patrik, thank you for that. This series this year was about the future of architecture, and you're showing us the future of architecture. I've always admired your work from 25 years ago, and quite frankly, I've been in awe of it and never understood it. I have to tell you that. Today, in this 1 hour session, you've completely changed my mind about your work. I now understand it, I think. But more importantly than that, tectonism is something that people have looked at and again don't really understand it. I don't think in our entire profession, because they haven't been educated on it. It's new, and as you said earlier, it's like the Villa Savoy. It's something that has started, and it's something that is in that movement stage where people are just starting to understand it, and those that are lucky enough to be in your classes and work in your offices, and people that have come from your offices truly understand it. But thank you for that presentation, and I'm glad to see the way that you actually broke this down into structural, environmental, and fabrication. That was incredibly clear. But just before I have a number of other questions. I want to bring somebody from your office on, and I'm going to introduce him. And if he can turn on his camera, please. Niels Fischer, if you can come on camera with us, please. So we can see you.
I think someone has stopped it because it was on when I joined. So I think the person who
Christina
earlier on has to switch it on again.
Christina, can you try and so we can see Niels? There he is. Okay, perfect. So welcome to this session. Niels joined ZHA in 2004 and has since developed a large design portfolio spanning Europe, the Middle East, and Asia. Niels has an academic background in architecture with a focus on experimental computational geometry. He studied in Germany and Italy and graduated from the Tectonics in Germany and Universität Darmstadt, and a diploma in architecture in 2002. Niels founded ZHA's Computational Design Research Group, CODE, developing next generational technologies, form finding and relationship. He also co-leads Cluster 1 and the largest business unit within ZHA, which focuses on cultural infrastructure and transportation projects. Welcome to this session.
Thank you.
Niels, I wonder if you can talk a little bit about your role with the firm and what you do with the firm.
I think it's kind of it's developed along with. I found it quite interesting to see Patrik's kind of review of the development, because that's kind of the very phase time that I spent in the office, and as you perhaps as you mentioned in your summary, I'm wearing more than one hat. So by the time I started, we were all very much about exploring new tools to develop our work, and I think that's pretty much congruent with what Patrik described as Parametricism 1.0, is making sense of the new forms and of the new kind of ontologies that we are faced with, and we had a really wild phase of experimentation there. And you mentioned the founding of our computational design research group, which was in exactly that period. And I have to say, I can't take all the credit for that. I co-founded it at the time, but we sat down at some point and said, we develop so many tools and we explore so many things. We need to start to systemize that also when it comes to the use and the maintenance of the tools that we generate. So it started really as an archiving project of all of the kind of on the fly kind of, let's say, inventions that we did when trying to use computers to develop and rationalize our geometries and systemize it. So this team really started as a project to conserve some of the methods that we came across when having a very intense dialogue with possible and impossible architectures. And then eventually we also saw how the development of these tools correlated with our ability to develop and visualize and explain and explore new forms of architectural expression. So I think the emergence of that team, which is now in excess of 20 strong, and it is very impactful in also tackling some of our most complex projects, is really happened in parallel with the growth and how our form language became prolific through our own projects, and then also through projects of our collaborators, and then let's say the wider group of contemporary architects working in that field.
Patrik or Niels, maybe you can shed a little light on, and Patrik, you touched on this in your presentation. You know, you have the architecture portion of what you're doing, and you're definitely moving forward in that area. But then you touched on, you know, the structural engineer, and you know, the Nervis and the Frei Otto, and you know, the Peter Rices of the world, and their contributions to project. Tell us a little bit about in Tectonism how that role is different than the traditional role previously, that in working with structural engineers, because, you know, with a Nervi, it was pretty easy because Nervi did everything, and he kind of did everything himself. You know, Peter Rice worked in a kind of a different world as well, and Calatrava works in his own world. But tell us in Tectonism and in your office how that works, because structural, as you pointed out, is a big part of your work.
That's right, and we have the ambition to really use innovative structure, and parametricism is the only style that actually allows for that. You know, even on the simplest fact, if you have a beam, it should have a moment line. It's an element which already breaks out of minimalism and is already in the domain of parametricism, and it would articulate more where's the center of the space, if you etc. So that this is clear that we would like to do it. And the examples, the key figures, if you look at Gaudi, Frei Otto, people like Felix Candela, but perhaps also somebody like Calatrava, you get this kind of synthesis, this integration. And these are both engineers and architects. Now, in the modern world, you really need the division of labor. But the collaboration should be super close, and architects need to not be responsible for, you need to congenially interact with, integrate, but also know the principles and be really demanding an active lead from the engineers. And during the period of postmodernism in particular, I think, deconstructivism, etc., there was this relationship where we would do wild things and we'd make a composition, and then the engineer is just waiting, and they would say yes to everything if it was possible at all. And that's not the way the collaboration. We really need to bring in, we need to, you know, have first principles thinking. And we also have these shortcut tools now, which give an initial sketch rationality, and we need to understand it. But then the engineer has to come in actively and prominently and be more confident. And that's what we need. That's what we want. We want to learn in every project and allow the engineering to really imprint more strongly. And that is the same with environmental engineering. And what is interesting, that the engineers in that kind of strange hierarchy of disciplines, where we meet the client first and we bring them in later, etc., there wasn't a culture. And I think that shift in culture, we have great engineers in London, and we start this also at DRL, for instance, and other studios where we bring in engineers early, also in the academic realm. So the intensity of collaboration is very, very important. And the active shaping input and confidence to do that, engineers need to be encouraged. I mean, it's still not there with respect to the culture, but that's what we need. And we do, in the best examples, that's happening.
Do you obviously on the engineering side, there's they have their own programs, they have their engineering programs. Are you working with the engineers on their engineering programs to bring them into what you're doing?
Well, we have shorthands, quick plugins, which deliver a kind of, you know, enough so that the significant morphologically architectural expression, feeling and concept can be brought on.
Yeah.
And you know, and in a way, the whole Tectonism movement has been proto-engineers. They went not only in terms of using these tools, developing these tools, but for instance, in terms of fabrication, you know, architecture schools in the last 15 years, they've been all kind of building end effectors, you trying to use robotics. they also try to be kind of material and fabrication engineers and proto fabrication engineers. And it takes a lot of, but eventually when it comes to professional work, you can't. But because the engineers weren't doing parametricism, weren't doing tectonism, we had to kind of lead them the way and then cry out. And you have examples like Achim with the Knippers kind of combination between the architectural and structural professorships where this has happened, because we can only go that far. But I think really, what's interestingly, it was pushed by the architects. The engineers were dragged into to help us. But the tools were ready in finite element analysis. But you can also use finite element analysis to calculate a Chipperfield project, except it doesn't show up as making a difference there.
Right.
I mean, maybe adding to that, I think we really love working with engineers who share our passion for first principle solutions, and because it gives us the understanding for the parameters that we need to meet. And I think what is interesting when it also comes to sharing tools with engineers, or perhaps not sharing them, is that we found out we are having a slightly different, let's say, dialogue with our models. We seek, I think, the solution space, and we then want to do an aesthetic excursus into that solution space, and then see what we can get out of it. Whereas I think in typical engineering, you look for the one optimized solution. We want to understand how far we can widen the solution space to then kind of interpret it from an aesthetic and architectural perspective. And we have great collaborations with engineers who help us to build tools for that. So in a way, we do not need the nth degree of precision in our analysis, in our very quick early stage analysis. We need, let's say, the 80% solution, but we need it very, very fast, so that we can start to almost intuitively interact with the model. And then once we are happy that we have something which is feasible, which is in the double positive quadrant, we then have the confidence to can say, yes, this is a design that we can take to the next stage of a project, and we have the confidence in it being something that can be efficiently resolved, right? And it's about really keeping that solution space wide and open and enabling a conversation with something which can be a quite challenging proposal at early stage, and buying us the freedom to explore solutions whilst gaining enough reassurance that what we do remains feasible.
Yeah, I think I just want to add to this. It's really spot on, because in Tongji, we actually had in that workshop, there was also one of the founders of topology optimization tools, that Chinese engineer, I forgot his name, who is teaching in Australia. And he realized the same thing. He was challenged that we don't want the solution, the optimum. We want spectrum, but the spectrum, let's say, where we're happy to say, okay, 5% give or take, we're in the right ballpark, that now give us 10 versions. And he has adapted his tools to deliver precisely that, where you can calibrate and tight, and really pushing variety of solution. And it's very interesting you said that, Neil. So that's exactly where this guy realized that he has to make himself fit for the way architects work, because we still not fully resolved with what the articulation should be and what's the best. We can't be force-fed and pressed into a preconceived structure, but we want a spectrum, all rational, to explore together with the engineer, and then have something which is rational and articulate. So that's very interesting. So engineers have kind of, this engineer in particular, I wish I would remember his name correctly. I guess it's Shi. Professor Shi was precisely doing that. So there's now these kind of tools which don't home in on the solution, but offer a kind of, and in the end you can say, yes, if we're in the right ballpark, 5% up or down, or even kind of within that range, if we can reach somewhere which satisfies other demands, but be an optimized still up to 90% at least, that's a wonderful thing. And that's where also engineers and architects have slightly different agendas, and we learn from each other, and we build a kind of symbiotic, complementary research trajectory. So these tools are now researching differently, not on a pure engineering agenda.
Patrik, can you talk a little bit about the research that you're doing both at the AIA, and are you doing research outside of the AA as well?
Yeah, so I mean, we have several research teams inside the office, which is one is geometry optimization, but there's AI, a whole team which Niels was also kind of instrumental installing, and we have a lot of talent there. We have more space planning and social functionality, agent-based system simulations for the occupancy patterns. We are attacking this on a number of levels, because also in terms of organizational fluidity and optimization with the ranging of the spaces, how do we know that this is socially functional in terms of encounter frequencies and communication densities across various populations? So we have multiple research teams, because this has to come together. This is also a new way of a Google campus. The way these institutions function is different. Yeah, so we're doing that inside the firm, and we're doing that with various schools of architecture. And I've also been using PhD research. So currently, I'm dedicated professor of international PhD program in Tongji University, China, Shanghai. And I've done a number of years at the Vienna University of Applied Arts with a PhD program there. And that kind of interfaces. But so with postgraduate, with student studios, you can illustrate and reach and inspire. PhDs, you can add some degree of rigor and scientific and gendered ambition. And then the office research team is really where it hits home. So we need to work on these levels. But without the students, without PhDs, you wouldn't quite set the problem right. So it's a synergy across platforms, across arenas, and we obviously really need as clients challenging us with projects where this finally is brought home.
Yeah. Well, compliments on the research, because I know that from a financial point of view, the in-house research is a bit of a drain, but it's one of those necessary things. You just touched on clients. Can you tell us a little bit about your clients today? Are they competitions or direct clients? What's the overall makeup of the 500 people that you have and working throughout the organization right now?
I'll let Niels pick that one up.
Yeah, so we acquire the vast majority, in excess of 60% of our projects, through competitions, which is, I think, also what we want to do, because I think we still, even after 40 years, I mean, I'm here for half of the time, 20 years, we still like to measure ourselves, and we like to find out whether our ideas are relevant, and it's by far the most relevant contributor to our project pipeline is competitions. A lot of them are public, a lot of them are anonymous. So we I would say we pride ourselves in winning most of our work in the field in competitions. And frankly, it's also what keeps people excited, because of course it also allows us to internally compete for the ideas. We very quickly find out, almost like in a genetic trial and error process, which ideas are relevant because they find an audience, right? So we do not want to isolate our development in a bubble where only people who like our work come to us and ask for more of it. We like to test those ideas, and again, I think it's same goes for research review. Yes, it's an investment, but for us it's also an employment factor, because it helps us to attract the caliber of people who then help us to produce the quality of work that we do. So I think it's also a very important factor enabling us to do our work, is to allow for research and make it part of, almost part of the package that you get when you come here, and I guess that's contributes significantly to the motivation of people to then go out there and challenge the world with their ideas. So competitions is by far the most important factor. And then, as Patrik mentioned, we have various research and support teams. So overall, they sum up to around about 50 over 500 people. So that's about 10% in specialist research groups that teams can can pull into their projects at various stages. So we have everything from very early conceptual, let's say, what I mentioned earlier, fast iterations of our possible structural solutions on very quick and highly optimized models for form exploration, all the way down to then optimizing office floor plates for efficiency of communication or commutation within a building, material optimization. We have a rapidly growing sustainability team that now also starts to program their own tools, because again, we often very quickly need to iterate over concepts rather than doing highly precise simulations. So we see kind of a repetition of what we have developed in the structural domain now happening in energy simulation for buildings, and also in embodied carpet simulation. So there's a very interesting now parallel in that domain that is kind of ingesting some of the approaches or some of the lessons we learned from structural optimization for conceptual designs, if that makes any sense.
Thank you. I'm going to ask Tobias Fellows, who's a principal with NORR in our Ottawa office, to come on screen. Tobias?
Hello, everyone.
Tobias has been gathering the questions from the audience. And Tobias, do you want to start off with questions from the audience?
Lots of great discussion in the chat. And I think this first question, I think, picks up on what you said, Niels, at the end about your sustainability group that's looking at embodied carbon. This question is about materials and waste streams. So they're asking, can you comment on sustainability, materials, framework, waste streams of these new large projects? And maybe like, how do your projects compare to more traditional delivered projects as far as embodied carbon and waste streams? Are you looking at that right now?
Patrik, do you want to?
Yes, I will come in later. I have some.
Yes, we do. And as I said, it's our youngest but fastest growing team. And I mean, there's one element is about learning about what we did in the past 2 years, and that's of course also telling us where we also have been wrong in the past. But what you see coming out of that very, very quickly is, and I think that's the beauty when you're used to working parametrically, that we can then very quickly take those learnings on board and adopt. And we see certain things kind of almost becoming an emergent quality of our designs is that, let's put it like that, I think it's fair to say that the better and the more aesthetically pleasing the outcome of our structural solution is, the more material efficient it is. I think that is one lesson that we learned very quickly, and I think we are now even further looking into the correlation between carbon footprint, but also adaptive reuse and structural efficiency. So I think that the prototypes that create hybrid materials which are bonded together, which can easily disassemble them. That's one thing. The other thing is, as we do not need to cast in anything, we can robotically print them. We get to hollow materials. So I think in a way it's the convergence of different streams of structural optimization and understanding the assembly mechanisms and the way things are put together, which allow us to leverage more energy efficient and resource efficient construction, and then ultimately also deconstruction. Because I think what we now really start to realize is that the way things are joined together, and we have a timber project coming up where we look at the dry jointed timber nodes for kind of larger structures that also are massively advantageous when it comes to giving those components a second life, because it doesn't end up on landfill. You can actually take it apart and make something else out of it. And these are things which are kind of very recently start to develop I say almost fascinating correlation in our work. It took a while to get these teams to a level where can they have that level of distance, but I think it really starts to come together now.
I just want to add, although I underline all this, and these are important aspects in terms of my thinking, where our particular contribution lies with Tectonism is not so much on the embodied carbon, but on the energy saving side of things. And that's also the side of things where, okay, of course, steel tonnage. Yes, there's a massive saving if we had intricate and if you exploit shell action, if you exploit fully the differentiation of elements and using them only where you need the tonnage reduction, and eventually this will really translate into costs where the complexity of fabrication will be coped with and will be reduced when firms gear up to the logistics and differentiation and robotic manufacturing. So there's a huge there. But in terms of, for us, exciting is the energy saving element. So the optimization was really what impacts the form, the morphology, these systems, where the shading is optimized with also less and less louvers, more and more shading, and where you have overshading from another building, you can lighten out the structural, as I said, differentiation and the overall form. So some key projects are like us, like the Saudi Arabia research campus or the Iraqi bank, where you can also see something going on. There's something intricate, something adaptive, and it shows up the new paradigm. Whereas if you would just with embodied carbon, you could, in theory, foreground that and say, okay, the architecture remains exactly the same. I'm just substituting this concrete for that concrete or this system and resourcing a route to another. So I do think these are important, but I think the tectonism drives will be more in towards energy saving and material saving. And I think that's something what I would foreground is, and it shows up. You can see the things, how they become morphological drivers, and of course these are direct economic savings for clients. Not only the running costs, very important, coming down, but also the amount of space you need for the machines. you have to pack in, and which get in the way of intricate intercommunication, intervisibility of all these machine floors and so and also these Porsches with pipes running and so on and so forth. So it is I'm foregrounding that as our specific contributions relative to, let everybody work on embodied carbon. My personal and in the firm there are many working on this. My focus is on this.
I think I just want to
running cost energy saving for the sake of the light-footed new architecture.
But I just want to throw one thing in the mix, which is, I think, very relevant to the way we design buildings in that context, and that is trying to understand how people read or how users read and use a building. So we have two research groups using different approaches for that, but essentially it's about understanding the relevance of the space that we built. And we find out that on a normal typical office floor plate, you only kind of use between 60 and 65% of that floor plate to kind of give it its meaning, which is doing productive work. Like you do not use the corners, you don't use the dark spaces, and we say let's not build them in the first place. And that is a kind of double-digit optimization potential that you do not find in any engineering discipline where a single percent is a gain. So if you think about the trickle-down effect on material use, on the weight of buildings, on the size of the buildings, on the size of the road nets that you need to connect them, on the footprint of our cities, there's a massive potential in just reflecting on the program of our buildings and how meaningful it is for the purpose we built them for. And I think this is where better design can have a massive impact that we haven't really started to tap into yet.
Amazing, yeah. And I think this next question kind of picks up on what Patrik was saying about the buildings being very responsive to their environment. In one way, they're, with the solar orientation of the sun coming in, and this question kind of, I guess, comes from the perspective of the built environment, and I think just the surroundings. How do and just let me find it here, just 1 second. Yeah, I guess, yeah, just like how do your buildings respond to the existing conditions? It seems like these are they're so different and you know, it's a completely new paradigm, as you're saying, Patrik. How do you get reactions from your work about you know, that they're not respecting the existing environment? But like, can you talk a little bit about just the visual change of your buildings and their impact on more traditional forms of architecture, and the responsiveness between your buildings and
Yeah.
their surroundings?
Yeah, no, absolutely. I mean, there's a number of aspects to consider. I mean, we have a number of projects where we're actually integrating with the existing structures directly, whether it's MAXI, the National Museum of Art and Architecture in Rome, or Antwerp, where we're going on top. You know, Oxford, the library embedded itself in an old kind of brick kind of architecture and media. It's like an amoeba between different things. So we love those. And the whole point of this kind of paradigm shift away from modernism, where you went out into the green fields, was starting with postmodernism, was the kind of urban renaissance and reintegrating into urban centers, historic centers, because of the knowledge economy, mixed use clusters. So that was been the founding problematic, which parametricism also responds to. And from Zaha's work, the earliest projects she's been working on, for instance, the Parliament in The Hague, is precisely this kind of layered condition. So but it doesn't necessarily imply, so that means that we can fit into irregular sites, that we can affiliate the project on the one side to this kind of grain and sets of entrances, and then we morph to meet another condition on the garden side. And only this kind of parametricism architecture has the repertoire and openness and versatility to do that. And that's fundamental. Of course, that means initially, so it is functionally better adapted, and it also invites and connects into the synergy networks. Why are you locating this building here to connect up with these neighboring buildings and have a functional relationship? We can do that. And of course, it initially would look rather alien. And that's something we can do very little about. And although there is some dimensions, because you can also always be to some extent quite different and other, and then you can pick up materiality, local materials, or the climate which you are facing. If this an environment is more traditional, they had to adapt to climatic. Only during the 50 years of modernism, you can be independent and just put a big machine and pump energy to make something generic. And then it's harder. It's anyway not characterful already. So there are some dimensions which remain open. So you can see with some of the projects, whether it's the Iraq project, the Riyadh project I'm mentioning, they are both decisively and recognizably 21st century, and they also have something of the locale and character of the environment. But also, I think this sense of alien and other, making things conspicuous. It's also, that's why we misunderstood, as if we wanted the spectacle and we wanted to be different and kind of conspicuous for the sake of being conspicuous. No, I mean, this is a bit like the stage we're at. If you think back, if you think about the Lever House in opposite, you know, let's say New York, when the Seagram's Tower landed in New York, and the Lever House, they were like alien spaceship in the kind of brownstone kind of environment. In 1950. 1990, look back, everything was remade in the image of. So these brownstones are still somewhere there, but not on the avenues. So that's also to be expected. And Zaha was saying once kind of, okay, if you want me to assimilate to crap, you get crap. I mean, it's a kind of stark sense that we should also be confident in what we're doing, but we have to distinguish in the environment, in the context, what are the assets which will remain, and what are the assets which will anyway be gone in 10 years. And we would then hope and expect that what then replaces is affiliating to us, rather than re-affiliating to something which is, and that depends where you are. Of course, in the center of London, it's a very, very mature build-up. But if you work in China, it makes sometimes not so much sense. Because these things are already kind of marked for demolition.
Yeah, I think this is an interesting question, kind of ties into what you're saying, is Can you talk about where do you see the big gaps in knowledge or understanding, and why a tectonism is not being more widely adopted?
Well, I mean, first of all, unfortunately, there's a certain conservatism in and risk averseness in some cities, clients, because they're very mature and you step on so many foots and you worry that you might get the unusual, might alert resistance. And then you try to be chameleon-like. Hopefully nobody noticed that I'm doing a new building here. This kind of, so that's a problem in cities like London. I mean, of course, there's still great things in the exceptional zone, which is the city of London, the financial district, where you have fabulous and fantastic. But everywhere else, it's kind of blending in, and there's a kind of, and I understand it from the investor's point of view. They don't want any, and it's hard enough, and you could be 5 years in planning. So that's unfortunate, but it is not really a really truly rational kind of motivation, and we should hope to overcome that. But on the other hand, it's this that, yes, what Silvia said, our work is often misunderstood. It's not understood the kind of how much it's driven by rationalization, by adapting to conditions, social functionality concerns. And because principally with new tools and new optimization and optimization tools, the outcome looks other, they think that's what we're about. And that hinders, and there's a kind of prejudice. That's one thing, but also particularly when it comes to tectonics in the latest iteration, even in our office, I mean, there is a hurdle of really, it's harder, it's more sophisticated. You need to know more tools, you need to consider more aspects. You need to early on have a confluence of agendas, and that makes it harder. And it's a more ambitious project, and that's why I hope we can use, the tools need to help us, AI hopefully. So it is a difficulty of that. I mean, it's a more, I mean, that new level of sophistication and rationality and optimality. It's not, it doesn't come cheap. It doesn't come, you can't shoot from the hip to get it. And sometimes that's the difficulty. We are challenged in competitions, large competitions with very severe deadlines, very rapidly. And that's why we need the research and theoretical projects to build up the capacities, as well as the teaching arenas, to gear up, to have ready repertoires and methodologies, which we're testing on some competitions where we have more time, but we've tested it in academic studies where you have a whole year. We're testing them on small pavilions, where the pressure isn't so high to get it right. So that's why we need it, because if you're under this continuous pressure of delivering things which do have to perform, we can do it, and we can deliver best value and more value, but we can only do it because we have that whole 10% of research, and we do it after 5-10 years into that research. We finally delivering. So we need that time of build-up to do it, and because that's hard to get by, and it remains at this point relatively rare.
Amazing. Patrik, this next question gets into the virtual. It's someone on an iPhone, no name. How do you understand and define virtual, simulated space, the virtual realm in architecture? Is this part of your research and your new paradigm? Might you comment on the relationship between the real and the virtual, which I'm sure you will have a
Absolutely.
answer.
Well, I'm actually, first of all, I don't like the distinction real versus virtual. I'm saying physical versus virtual, and they're both equally real, because we're talking about real life translating into virtual spaces. And our event is real, a real discussion, learning opportunity for many. And all we have of each other is a grid of you know, the virtual world designed by a graphic designer. And now in virtual interaction spaces, now architects will start design them. And we actually entrepreneurs, we just incorporated Metrotopia, and we have already something up and running. It's a metaverse interaction space for the design disciplines, particularly with the exhibition spaces, event spaces, and many architects already showing their work there, and with panel discussions and events and exhibition openings. So we believe that this will come, and that architects will design this version of the internet, the immersive, real-time interactive internet. And rather than graphic designers having delivered the internet up to now, as in terms of the design disciplines, and there's, you know, every artifact has a designer at some point, there will all, and engineers. So there are also metaverse engineers in the background. So that's what I believe, and I think it's fully within the domain of architecture, because it is architecture about organizing and articulating and framing communicative interaction, the knowledge economy. That's most important, where we all work. It's not necessarily physical work, but communication work, where we need to learn, interact, collaborate. And the metaverse also allows for collaboration. So we're looking at, we're building virtual interaction tools where you gather in a space and you load up a model and you sketch over that in 3D in a space, and you spin up another screen, and you make a discussion or spin up another model and jump into the model. So we're developing these tools in-house, and we're developing a platform for in this case, tailored towards all the design disciplines, schools of architecture, architecture, urbanism, industrial design. I'm a strong believer in it, and it's not video games. This is serious, professional, and cultural environments of engagement, which I believe, though, we'll use and not fully translate into. And a lot of companies will have virtual spaces, but they maintain also physical premises. And we can offer to them both. You can, we will build that next, museum or extension, and we build both physical and virtual, and the virtual comes first and allows us to learn about the physical. And then the virtual space will be projected as an extension of the physical when you're there, because I believe that the metaverse will not only consume from home, from a kind of laptop or headset, but we will collectively be in a space surrounded by big screens and cave-like virtual extensions. So I'm a great believer in this, and parametricism is, again, because the functionality is very similar. Many people interacting, seeing many things, navigating, and joining a city of events where things aggregate according to synergies. And if I see something here, I'm also be inspired what else is in surrounding this event where I was. It's like a kind of contemporary city. I believe in that, and we are, as architects, we should take it seriously. It is architecture proper in terms of my definition of architecture. And what was lovely about that first of all, the computational tools will become important. There will be many more spaces, there will be an avalanche of design. So we need all these tools, and they will be renovated much quicker and evolve much quicker. So the amount of design we have to do for these worlds is going to be monumental, and AI will come also. But what was the most important for young architects, they can compete with us. You don't need that 40 years or 30-year track record necessarily. You can jump in and be a fast competitor in the virtual world, and I find it satisfying.
I think maybe just to throw in the mix on that point, because I just realized, Patrik, I think this launched today. You can't see it because I have a filter here, which is, let me unfilter that. I mean, I can just explain what it is. We just launched a project today with Epic Games, bringing a modeling toolkit for London onto Fortnite, which is using something which is super prolific. Everyone has kind of a gaming console or a mobile phone you can play these games on at home, and everyone knows how to, I mean, it's funny enough, the average gamer is like 36, 37 years old. Everyone knows how to navigate a game and explore space. And we've developed a project with Epic that we call Reimagine London, where you can use a construction kit to, in a way, comment on the city by making changes and proposals to it. And the background of this is that we believe that there's a massive potential for improving public consultation by allowing people to test drive their environment before you actually go out there and spend millions or even billions to build and then find out that it maybe didn't work. So there's an amazing potential also to communicate about architecture and let's say let society form a view on proposals that is inherent in these very immersive environments. You do not need to have an expert training anymore to understand a plan. If you ever try to look at a planning consultation in London, you download abstract elevations and most people cannot make sense of it. This is a completely new way for people to get immersed in unbuilt environments, and then at the same time you can also see how people interact with it. Are there attractive places that people gravitate towards? Like, I mean, it's a very important metric when you want to have a lively urban environment, to understand how footfall works. And there are now very, very beautiful opportunities to create highly immersive environments that are just fun to explore and then also learn something about unbuilt cities. And this is I think there's a massive potential to use instances of an unbuilt reality to improve our actual built world around us. Yeah.
Very interesting. Just to pick up on there seems to be this kind of split between the virtual and the physical, but now through COVID we're exploring hybrid environments, and I'm wondering is your research looking to kind of blend these things together more more kind of in an integrated way? Are you looking at how you can bring the virtual environments into the physical environments beyond just looking at sitting down at a desk looking at a screen or eye goggles? How do you see hybrid environments?
I mean, absolutely. And I mean, COVID brought the whole thing on, and I had a whole studio at DRL is called Cyber Urban Integration, where the whole topic is that we had virtual spaces which were not purely virtual, but were embedding themselves in physical architectures. So there's an atrium which becomes a cave, and you witness and perceive a lot of hybrid events where you have a crowd, physical co-present crowd meeting and engaging with a virtually assembled crowd in one space, where the screen, the trompe-l'oeil kind of expansion of the physical space is designed at the same time together with the physical space. And you have a kind of world where a lot of surfaces, I mean, you can't do it with rectilinear TV screens. You need to kind of have, much more larger immersive screens, holographic. So we had this program, and of course the experience was and still is, many of our events are hybrid. Nearly every meeting is hybrid in the office, nearly every teaching and jury is hybrid, many lectures and conferences are hybrid, where you have people sitting next to screens where you beam in, or and so at the moment the tools are not quite make that seamless. But Zoom and Microsoft and Meta, they're all working on that as well. Not on the pure virtual, but also on and we have been in communication with some of these companies, and it's a big possibility, because I do think it would be a shame if, let's say, if the virtual turns out very efficient and super fantastic, but we would all be kind of isolated at home, and no, we should have these hybrid conditions where we have physical co-location together with virtual integration, and groups coming together, several groups meeting virtually, but each group or one co-located group with a dispersed virtual extension. That's what I think should happen, will happen. Also urban surfaces, these big kind of dot matrices and screens become ever larger, and so that's something I think which will probably happen, because we do want that. And it was for me fascinating that during COVID, when people were all working from home, of course something got lost, and something can be regained in the metaverse, but something should always be I still believe that will be this cyber urban integration in concentrated urban centers, and we won't be on the gateway to a re-suburbanization where everybody sits at home on like a couch potato.
Yeah. we've got a question here from McIntyre Garber. As postmodernism was a radical counter proposal to modernism, do you see a counter to tectonism?
Well, not yet. I mean, what I believe is it's not, these movements are not just inventions. Oh, let's do something new. They emerge out of a moment of crisis, which necessitates some kind of search and restart. And then the solution also, they need to fit in. So that's why I'm saying these focal styles align with socioeconomic eras. And there's also, and you can go back, you can see that the Renaissance of the first conscious architectural style was tying in with early city-state and early capitalism. And then Baroque aligns with the absolute state of an integrated national economy, with large government centers, Versailles or the Vatican, etc., and larger buildings and structures where Renaissance couldn't deliver, and also in terms of urbanism and so on and so forth. So historicism, neoclassicism and historicism is the bourgeois era, post-French Revolution, and a new kind of sets of institutions, not only churches and palaces, but many other kind of institutions of the bourgeois, or kind of more developed laissez-faire capitalism. Modernism aligns with technology, but also with the socialist revolutions and post-Third World War social revolutions, and the masses become clients, and you have factories, housing, everything becoming into the domain of architecture, which was excluded before and remained vernacular. So all of these things, and then let's say I said, postmodernism comes at an era where you have what I say, the computational revolution, which is then expressed also in the sense of the kind of Thatcher Reagan neoliberal revolution away from let's say the socialist or semi-nationalized mass mechanical society. So it's, having said that, so we really need the new paradigm and style will come when you have a new transformation, significant socioeconomic, mostly technology introduced, but also then the repercussions of technology into sociological dynamics. That will bring on the new style, epochal style. And then between epochal styles, you will have these phenomena which are called transitional styles. So it's not a matter of inventing. What is a matter more of inventing and more scope is within a paradigm that where within modernism there's very subsidiary styles which you can more invent, but of course you have to be convincing. It has to tie into something. So brutalism comes along also with the scaling up of the projects which are brought under the spell of modernism, etc. So I think this is not as a matter purely on the ideological plane, as it were. Of course, you need the ideological plane. You need the protagonists. You need the ones, the pioneers, the avant-gardists, the thinkers, to push forward. And you need also artistic experimentation. You needed modern art to generate modern architecture, and you can see that in the Bauhaus. But once this was established, you then work through, and the artists disappeared. In 1925, there were no artists left, and it wasn't working through. And Hannes Meyer took over, etc., etc. So these things have much more, let's say, gravity of real life conditions, and they're not, a kind of severed off realm of pure invention and so on. And you can invent into the and these will all be stillborn inventions if you're on as the phrase says, on the wrong side of history. But I know that parametricism and tectonism are on the right side of history, so they will eventually come through. I have no doubt. But it's not about, and so what comes around beyond, it's difficult to predict, because we don't know where this civilization is still working through, is still building the post-Fordist network society. The only glimpse, I think, where there's something could be, if that metaverse condition would really take off in the way of killing the city, then we would be in a new domain. but I do still believe that the virtual spaces would still be parametricism, by the way, because so parametricism will continue, and I don't know. I don't think anybody could have predicted the Industrial Revolution and the transformed, and what modernism might be looking like in the 19th century. So I refuse to predict. All I know is if there's massive transformations which change societal dynamics and ways of life, yes, architecture will have to follow suit, but I have no idea. And I wouldn't expect it to come, as a pure invention. It can never be that.
We've got, this is a question, Patrik, from Hassan Safarini, who is our principal architect at NORR. This is fascinating. The conceptualization as I see
sorry,
it.
so I just have a correction. He's our principal structural engineer.
Okay, sorry. Yeah, the conceptualization as I see it is neither only architecture nor structural. Furthermore, without enormous computational power, these forms cannot evolve. Some have argued that even more unfathomable forms will eventually be generated by AI once the tools are integrated with the AI power and associated with computer power. With this presentation, I dare not imagine what these future forms will look like. Any comment?
Yes, I mean, absolutely true, but I see some avenues already. I mean, one thing first of all, 3D printing going more universally. So what you can then go into, you can not only differentiate the global form, the network of elements, the joints, etc. You can go into the material itself and differentiate, from hard to soft, like bones, or into ligaments, into, and so there's an avenue. And I think, I'm sure there's a lot of rationality and optimization potentials there. And of course, computing that must be, yes, in terms of polygon counts, and is another level, and also 3D printing technology. Although we have we started beautifully 3D printing, but only of models, not of buildings, in our office, or robot arms. So yes, I can see some avenues, and of course, yeah, it's just. I think, and maybe Niels can comment. I mean, the computational power, the AI stuff we're doing now, and also, for instance, metaverse, what we're doing now and what we're showing 3 years ago was absolutely impossible. And so I think there's this,
Yeah, I mean, I had a thought when I listened to your rebates. It's quite nice, an opportunity to just reflect when you see kind of where we started and where we are now. And then I thought, okay, where is this going? And I think it's quite interesting when you look at kind of what we kind of really did in our initial project, like understanding what is let's say, is kind of Euclidean composition. How is that different from a small or blob? And working through all of these kind of very, very elemental bits. Looking back, that's quite low complexity. But what I see is an increasing affordability of complexity, but not for complexity's sake, but for the sake of increasing the relevance of a design. And I wonder if you extrapolate that, like 20 more years ahead, and then you throw AI and let's say, I would not say more computation, but more affordable computation, as in more efficient and more relevant computation. This is the nice thing, because AI allows you to take a shortcut through a lot of number crunching that you would do in fluid dynamics or FEM, which is very, very computationally intense. And I think that through AI, we get to much more affordable computational solutions and much more relevant ones. But I just wonder, if you extract all of that, don't we then kind of arrive almost at a recreation of the evolutionary process and very, very kind of biomimical, or let's say biologically analog forms? I mean, if you want to kind of cast it into words, like wouldn't tectonism eventually not kind of result in a form of almost like geneticism, even though that can sound very different, but or I mean, in an architectural sense, where we can accelerate the evolution of ideas and the optimization of forms to then synthesize kind of almost like, let's say, organic response to a problem.
Absolutely, I believe you're right, and they will have share a lot of feature with the organic world, but of course there will be totally new species and creatures in their own right.
Yeah.
And you know, in paradigms like artificial life have been fascinating, and how you could evolve structure sort of primitives, you know, in some kind of selection pressure environment dynamically, or as an ecology of creatures and species. I mean, yes, and I agree that of course AI it generates these kind of computational shortcuts, but you need you need to have a lot of samples of fluid dynamics. You need a lot of samples of topology optimization to train up the AI. So there will still be that crunch point. But yeah, I think it's a fascinating world, and I'm just still struck by how rapid this evolution has been in recent years, and how a paradigm like neural networks, which was kind of put on the back burner and disappeared, has been kind of re-emerging and impacting. But we have, but I still would say at this stage, the kind of algorithms generative algorithms and evolutionary algorithms, geometric algorithms and optimization tools we've been working with, and which engineers have been working with, have been more potent to this point than the current kind of image-based AI. But AI now goes also 3D, and you can do similar things with 3D and to interface these systems, because the AI always requires a sample set.
Yeah.
And where do you get this from?
I mean, this is an interesting because I mean this is, and I'm not sure whether that was clear, because we kind of do it and we don't really talk about it anymore. But when you look at the examples, Patrik, that you showed earlier, also from your work at Tongji, what we do there, we actually train models for specific purpose, and that's particularly relevant to Tectonism, because we kind of need to teach general purpose AI how a good structural connection looks like, and eventually it picks up on it. But the interesting thing is that we are working with a derivative. Yeah, we're working with an image of an idea. We're not working with the idea itself. And when you look at how you can describe particularly structures as a topology in language models, in code, then think of what you can do if you have collected enough of these descriptions of code to then use large language models. What happens now with GitHub, where you have autocomplete for your computer code. I think our problem in architecture is that we have way more images than we have systematic descriptions of buildings, but you can describe them, and there is already ways to read and process that. And I recently had a conversation with someone doing language models at Google. I think our challenge is that we just need to generate enough relevant data to start processing meaningful structures and topologies in large language models, and that will be the next really big boost, because we get away from these kind of slightly implausible and dreamlike interpretations of architecture to models that deal with the very substance, which is the hierarchy of elements and the way they are connected. And this technology exists already. It's being used in other domains. We simply do not have enough data yet to train them. And I think that's the next consideration for us as architects is how do we find notation forms or derive from built architecture notations that we can process in large language models. And it's already proven what these models can do in other domains. And I think we are just very shy of being able to generate relevant training data to apply these models. And I think that will have it will be a different order of magnitude of impact this will have compared to image generating models.
I mean, and that's important. I mean, at this stage, the level of maturity of tectonism and architecture with these ambitions, the discipline has to change cast of character, schooling and learning cycles, discursive organs. I mean, because we're still there's an inertia in these kinds of institutional and organizational and ideological kind of substrata out of the revolutionary period, which delivered postmodernism and deconstructivism and early folding in architecture, etc., which was basically artists and mavericks and art school-like schools, which had to do the brainstorming in the transition period. But also a lot was lost, which modernism after 50, 60 years had achieved in the 70s, in terms of systems theory, operations research, architectural planning, structures and rationality, and the scientific kind of paradigm, which you can see in people like Christopher Alexander in the Cambridge school around Philip Stedman, out of which also CAD system was evolved, and or Sheikh Grumman and so on. That's the modernist, and we have to kind of re-get back. So there's a kind of cultural shift also in the self-understanding of the field when we're not in that stage of revolutionary paradigm shift, but cumulatively building and delivering the promises of the early visions. And that's what the current schools of architecture are not geared up to. I mean, there are pockets which we know and we connect with globally, whether it's Tongji or AADOL or here and there. But if you look at the global discourse and the schools of architecture, and also what certain exhibitions and biennales and magazines of architecture, they are miles away from that. I mean, we are too thinly spread. And I think that there needs to be a shift to realize that. And we need to bring everybody, a larger group of people on board on this collective project, which we are too thinly spread to deliver that, or we get really old trying to deliver that. So we need to accelerate. And that's I think the kind of pitch I've been making. And
Patrik, I think I'd like to conclude this session with that. I'd like to just give you an analogy how far we have actually come in the last 40 years. You joined Zaha Hadid's office in 1988. In 1988, I had just joined NORR. I actually joined in 1986 after working with another firm for about 10 years. And I was involved in a small project that was Sky Dome, and it was the world's first retractable stadium roof. It was an 8-acre roof. And just to show you how far you have come and brought us, that roof had structural drawings on it. It had 4 panels, and the engineers gave us drawings with X, Y, Z coordinates for all of the nodes in the roof, and that's how we drew the roof. So it's unbelievably exciting and fantastic, and I think all the students that are online don't even understand what I'm talking about when I talk about X, Y, Z coordinates and nodes. But it's just truly amazing how far we've come in the last 40 years in this profession. And truly this session has been one, certainly in my mind, for the students that are online, one about the future of architecture and what your firm is doing, and your teaching at the AA and the research that you're doing. And I think that the research that architectural firms, that architects are doing today is absolutely critical. And it's one of the reasons that we do NORRED, and this is one of the sessions that'll go down in history. So thank you, Patrik, for doing this. Niles, thank you for your contribution today. Thanks, Tobias, for being part of this. And hopefully we'll be able to do this in a few years and see where we are. Thank you again.
Thank you.
Thanks.
Thanks, everyone.
Bye-bye.
Bye.